I'm Ishan, as you introduced me. And I really want to talk about like how like AI agents, LLMs are like in the hype right now, right? And I've tried a stab at like creating like an AI agent of my own or using Claude code and stuff like that. But always the end thing that I wanna answer is like what exactly did the agent do and why did it do that, right? Let's talk a bit more about it. How many of you have like tried creating like an AI agentic app, like LLM app, or used Claude code, Cursor, like anything related to AI, like in recent days? Enough. Nice. So I think a lot of you who use like Cursor Claude code would have understood like alright, LLMs like hallucinate a lot. Like you ask it to do something, it will change your entire code, delete your databases, delete your tables and stuff like that. It has happened to me, been the victim. Right. And at the end of the day, when you look at the results, you're like, this was not this was not cheap. This was like an expensive operation for a failed operation as well. Right. Uh, this is an example from Google as well. Like I don't know how many people like you in their food, but I personally don't. But that's what Google recommends, or like Google AI recommends, I guess. I want to talk about like why exactly these issues happen, and is there a way that we can fix them, or like at least try an effort, or have an effort to fix these issues, right? Let's use this as an example itself. Like, what do you think exactly happened? Like, was there a wrong context? Was the chunk not correct? The system prompt was not right, or the like LLM hallucinated, right? So, what exactly happened? To understand like what the agent did, we need to see the entire sequence of events, like what tools were used, what API calls were made. So we need the trace, right? We need to see the trace. Ultimately, we never know what our AI application will do until the users use it. We always have new data with new users, and this is applicable for any application, but with AI, it's a lot more applicable nowadays. Right. This is an example. We created like an AI assistant. We trained it for like, alright, how to create like an alert. But what the users were asking was like, how to create like an alert with XYZ resources in XYZ language. Right. AI assistant did not work. Right. This was like, LLMs are not ready for stuff that we do, right? The other aspect is like, these are not cheap. This is the cost that you see like one day usage I have, right? And I asked it like to do small tasks, right? So LLMs are not cheap. We want to understand like what LLMs use the most, like are the most expensive, what tools use the most, which users are using the most, or like how expensive are they? Right. I wanted to give you a small understanding on what the issues we've seen with AI agents and LLMs. I think all of us are aware of these. Right. Let's talk more about like how do we observe them. Right. In observability, we have three main things like metrics, traces, and logs. Metrics and traces. Metrics are like system overview over specific duration. Logs are like timestamp strings at the end of the day. And traces are the most important, specifically for AI agents. As I said, like we want to understand the sequence of events for these agents. Right. Let's understand what is a trace. A trace, at the end of the day, is just a unique identifier like this, right? It's just a number, right? But what makes a trace more like a trace are these spans, right? The individual lines that you see here are these spans. And spans are the ones that have span attributes. And span attributes are the ones that have like the entire information for it. I made a call to OpenAI. What was the input? What was the output? What was the response, the cost, the tokens, everything. Those are all captured within the span attributes itself. Alright. Good. We understand what a trace, observability, and everything is. Right. I think all of us being here have worked with software, created applications at the end of the day. Right. Initially, like earlier, we used to just have like, alright, this is an API call, it would be a successful API call or like a failed API call. Right. Then LLMs came into play where we gave an input and a response came. It was still constrained to an extent, like already we like asked the LLM for a specific thing like Olympics, let's say, and last answer related to Olympics, right? But AI agents came and there's no boundaries as such. Like you can do anything that you want. You can And you can get like answers which vary from one to one area to the another, right? Also, if you see, if you see this was intention just to highlight like LLMs hallucinate. This picture was entirely created by an LLM, like an AI. So all of the issues that you see are like AI issues, right? And that's what you want to fix. Nice. As I said, like now software and AI are different. Like, but do their observability is also a bit different. To be honest, yes, because with software we had API calls. We, as I said, like it was we could understand already. It's a successful API call, failed API call. We could easily debug by using classical APM tools, understand the trace, the duration, the latency, stuff like that, right? But with AI, we can't really care about like latency and duration are like still important. But at the end of the day, we still want to make sure like what the agent responded to the user, right? Was that the right thing or not? Correct. So for this, we need to see the entire trace, the conversations which happened, tools that we used, the system prompt and everything, right? Now that we understand LLM observability or like AI observability in general is different, there are two aspects to AI observability, I would say. One is LLM observability, where you just observe the LLM API call, right? You made a like Anthropic API call, you see the prompt, you see the response, you see the cost, you see the tokens, that's all. A single term, basically, right? The second is the agentic observability, where you want to observe like first input that the user had to the last output the agent did, right? Which I'll also show an example for, where like an agent has like a lot more runs. Like it'll use a tool, it'll use a LLM call, it'll insert like things into the DB, it'll search the web and stuff like that, right? Cool. How many of you have seen this logo before? Just nice, lot. So OTel is basically the data standard that we want to build AI observability on. We've understood like the need for AI observability or like LLM agentic observability. We've understood what things we want to like. How do we? The trace is the most important factor, but what's the data standard? And that's where OTel plays into. The classical way to define, like in my mind, is like OTel is like the USB-C of observability. We can integrate with any observability tool that you have, right? That's a USB-C. It's also the de facto standard. Like a lot of industries are spending a lot of, like expensing a lot on this itself. The major impact of OTel in this space has been where I defined like span attributes, right? How do we define like, alright, the prompt is in a span attribute, but what is the name, the key for that span attribute? That's also defined by the OTel community. There's a schema for like, alright, this is the key for the span attribute, the prompt, this is the key for the response. This is how it looks like, right? There's a full schema so that anyone goes to any observability tool or anyone can understand like, alright, this is the key, this is the meaning of the right. I want to quickly show like how do you add then observability to your agents. One way which is like very simple. You change the runtime of your application. This is the OTel SDK itself. You add it, but at the end of the day, you only get like information about your latency, duration, success, failures. That's all. You don't get the information around like what was the prompt, what was the response, which is what we were looking for, right? The another way is like the code is very small intentionally because like you have to make a lot of changes in your application code. This is not stable. This is it is stable but like long, very slow. Like I would not recommend that process. The second area that I would, the one tool that I would recommend is like if you wanted the simplicity of the runtime change and like a single line change itself. Like this is an open source library. We don't own this. This is completely open source. And this is what helps us instrument my AI application. I change my runtime and I would start having the information about like prompt and response flowing into the observability database, right? You can use any visualization. In this example I'm showing, I'll just use the visualization here and show you how it works, right? all of us, like all of you can scan this QR code if you want. This is the code repo for the thing that I want to show. You can run it later as well. If you need time, I can show that QR code later as well. So I have this trip agent, which will all it'll do is plan a trip to, like, let's say Stockholm for me, right? I want, let's see, it'll ask me a few things. Let's see, I want to go to Stockholm. Is this visible, or like do I need to zoom in a bit more? Cool. I'm here for like 4 days. I'm traveling alone. I have, let's say, a lot of money to spend, $3,000. The dates are fine, let's say. I guess, what should I be doing in Stockholm? History? I'm vegan, so I don't know how good vegan food is in Stockholm, so let's say food as well. And let's say I want to stay in a luxury experience, right? So the agent would do stuff, like it'll create like sub-agent, it'll call tools and stuff like that. I'm not waiting for, since this is a short talk, I don't want to wait for the agent to launch it, so hence I ran this beforehand itself. Once, like all I did, I think if you would have noticed, is like I just ran, all I did was change my runtime, like I added open it instrument, and I have the data flow in it, right? And as you can see, like I have the cost, the tokens, the information around, like the system metrics, the system overview over a specific duration. I have that information. But like the most important thing was the trace itself, right? And this is exactly what I want to show. The trace could like appear very big. Obviously, there are like a lot of spans inside this. But you could see like, alright, there was a specific agent was involved, a chat, API call was made, or like a tool was used, right? And if we, let's say, open the chat span, I can actually see, alright, what was passed to the open API call, the prompts, the inputs, the outputs, and stuff like that, right? And I think what would be more important for like system admin would also be like the cost for each request, which is like very, very important since LLMs are not cheap, right? Cool. The demo kind of works, or like we would not know since I didn't show the results of that. Alright. Now we have like the data flowing in from observability. Like we have the traces, we know what the agent did, right? From the first input of the user to the last output from the AI agent, or like the LLM, right? But what we are still missing is like, did the agent do the right thing? Like, was the last response the right thing? Like, was the trip like a great trip, or like it hallucinated, or what? Yeah, right. Sorry. So even in evaluations, like when we want to evaluate, like, alright, was the LLM response right? There are two ways. Like for LLM observability, we just compare, like for a specific request, we just say, alright, this was the prompt from the user, this was the response from the LLM, compare. Right? It can be any example. I asked for a trip to Stockholm, it did like a trip to Vienna, let's say, right? It hallucinated. I don't know how, like this is also an example, and not there was an example, but yeah, this could also be an example, right? Multi-tone evals are where, like, if you have an agent, that's where multi-tone evals would be the most important. And I'll show an example on how it could be. There's no specific solution out there right now, like which I'm aware of. Still open to like ideas around that. But like what in this I want to understand, like as I say, like from the first user input to the last AI response, right? Yep. Let's use this. Again, this is, I'm just using this as an example, but you can use any tool to be honest. Right now I'm just trying to explain the trace, like using AI, explaining what the AI did itself, right? That's not exactly what I'm interested in, I'm just waiting for that run to happen. Again, I had that run before, I don't know where that went. Yes. Yeah. So again, like how evals work is like we use another AI to evaluate the first AI. Again, some people can say how long do we do that? Like having another AI to evaluate the first AI. Like this cycle can be an open, like infinite loop, right? But generally the idea is to stop at like one AI evaluation itself, don't evaluate the evaluator agent itself, right? And I can explain why if anyone's interested. But yes, like what I would want to do, like there's no specific tool, so I just shared the entire trace to an AI. It shared like all right. There was these issues were there. Again, the trace that I analyzed was like very simple. But I think last time, when I was analyzing it, I had passed the. I don't know if you saw the trip was planned for like 2 days. The dates were like 2 days, but the amount of days I entered in the input were like 4. So the AI should have hallucinated around that, and it did, right? And that's why I wanted to test. In this case, obviously I did not share any inputs, as you can see. So it went fast as such. But yes, at the end of the day, the observability is like what gets you the data flowing in. You have the data, you can see it manually, spend time, waste your resources. And then the second part is like you can always use an AI to evaluate like whatever data you've ingested in your observability database. Sorry. Cool. I think I ran through it fast. But any questions? To be honest, like around this, it did run a bit fast, so there could be aspects which were not very clear.
Anyone?
That clear? But yeah, if anyone needs slides, in case anyone wants more clarity, you can DM me on LinkedIn. Happy to share.
Okay, thank you very much.